In this video, I will be addressing some further research design challenges that research might be exposed to. So while the Research Design 2001 text is this classical textbook chapter that provides an overview and some general strengths and weaknesses, then this AMJ 2011 text is on a more advanced level and trying to provide insight into some additional and challenges that a research design might face. So in an exam situation, don't expect all of these to come into play, but you might have an opportunity to identify that one or some of these challenges are in play in the description of the research design. So again, this text is written for researchers and it's trying to outline what are some typical pitfalls, some typical reasons for why a submission of a paper to one of these world's leading scientific journals might be rejected. So it's trying to outline some typical flaws, some typical things to pay attention to. And I'll go through each of these in the coming slides. But also note what they write here, that there are no hard and fast rules to apply here. So matching research design to research question is as much as art as in science. So these rules are not completely clear cut. Sometimes there can be ambiguity, but it's important to know about these criteria and these potential pitfalls, because it can help us develop stronger research designs, and it can help us identify a given study that we read about, whether it's a newspaper or a textbook or a scientific article. It might help us say, look, they actually overlooked this, or due to this particular reason, we should have less trust in the results. So let me try to go through each of these elements here. So one of the main elements that I've also addressed in the former video is that if you have cross-sectional data, it is difficult to address change. So let's say that you have data from 2015 and you have data from 1,000 companies, and you know which companies had an increase in productivity and you know which companies had an increase in salary. You will not, based on such a cross-sectional data set where you only have data from one point in time, it is difficult to know whether it's productivity that led to an increase in salary, or whether the company offered an increase in salary and the expectation of this then led to a later increase in productivity. It's difficult to pinpoint the direction of this arrow here. When it comes to sunshine and eating ice cream, we know that eating more ice cream doesn't lead to more sunshine. So we know it's this way around. But often in organizational context and business context, we might not really know in advance what the direction of the arrow, what the direction of the causality is. In this case, if you had insight into the productivity in 15, 16, and 17, and simultaneously, if you also had insight into salaries, you might be able to see that salary increased first. Salaries increased already in 15 and 16, and then only at the end of 16 and in the beginning of 17, 18, productivity began to increase. Let's say you had data on a monthly basis. In this way, you would have longitudinal data, you would have data on multiple time points, and you would have a stronger foundation to be certain that it's actually that the arrow has a certain direction. Of course, you could also do an experimental design, have 1,000 companies, 500 of them will increase salary, 500 will not, and then see if that influences productivity. There's also some fancy statistical analyses you can do. This is not something we'll be getting into. But this is just one of the general points that we often see, and also this, if you remember from the causality correlation video, I talked about this overview of 50 most shared posts on social media. This is what often happens, is that they will have data on one point in time and then end up making a causal argument, even though that there could be many other reasons for why we see a correlation. Next element to look at is what we call omitted variable bias. This is when we have the situation where an important variable or important data is not collected, and this could then lead us into a wrong direction. So at the bottom here, I've outlined the student bookshelf and future salaries, sort of maybe a little bit of a silly example, but it still gives you an insight. We might be in a situation where we can say that the more books there are in a student's home, the better the academic achievement the student will reach. This is a correlation that is very likely true. The more books there are in the homes of of a student, the more books that were in the home when the student was growing up at his parents' house, the better and the higher the academic achievement. But this kind of sort of setup might make you think, well, let's just put more books into the house of families, because then more people will end up have a stronger academic achievement. And that's probably not the right way to think of the causality, because it's probably the parents' intelligence or educational attainment that decides whether there are many books in the home, and it's also the parents' educational level and the sort of the parent push towards the students' future education that then influences academic achievement. So yes, parents influence the number of books in the home of families, but they also, and probably more importantly, in other way, influences the academic achievement of students. So this is an example of, if you'd only collected data on number of books and academic achievement, you won't get to the actual variables that really are important. One could also imagine an example of COVID-19, and we could look at different countries and then see how many people die of COVID-19, and then we could sort of lead that into a conclusion of, well, certain countries are better at preventing COVID-19 death than others. If we don't consider that different countries have different demographics, so different countries have more or less number of old people, and the fact that older people are more at risk of dying of COVID-19, well, then we risk making the wrong conclusion that certain countries are better at preventing COVID-19, while the main reason actually could just be that some countries or some areas simply have fewer people of old age, which is then the reason why they have less people dying of COVID-19. So I could sort of continue to make lots of more examples. The point is that we should be cautious about trusting any relation between X and Y until we've made sure that there isn't any other variable out there that is correlated to this and that is actually playing the key role. In the example of the elementary school study and how different points of time in the day had an influence on how well they did the tests, well, if it turns out that the students that were really, really good also got the test early in the day, well, then you've omitted an important variable, which then influences and skews and destroys your conclusion. So again, it's always important to try to have data on all the relevant variables. And this is then also, again, the advantage of an experimental setup, because you can control that there isn't any sort of random or systematic variation. There isn't any systematic variation going on that we can't control. So omitted variable bias. We often also see inappropriate samples being used. So let's say you're interested in how top management engages in decision making, and then one might run a study, for instance, a laboratory experimental study where you used regular students to try to dive into this issue. Well, that might not help understand how top management makes decisions, because these students are not by definition yet top management. So maybe you could use MBA students, but actually you really want data from CSOs to really make sure that whatever you end up finding out really matters for how top management makes decisions. One could also imagine a study on whether face masks actually help prevent COVID-19, and if this study has been done on nurses and doctors and shows how well they are able to use masks to prevent getting COVID-19, well, that might not necessarily translate to the rest of the population who doesn't have the same training in using masks. So again, one would have to make sure that you don't just sort of transfer insights from how specialists are able to use masks to the everyday population. So make sure that when one assesses the conclusions of a research study, one looks at the data and ensures that whoever is sort of the foundation in the data set, what the data that you've collected and the people you've collected data on, that they're actually also relevant for the conclusion that you're trying to draw. Another example of this is sort of slightly different example is Google. And Google, the company, has realized that general test scores, what they call SAT scores in the United States, or grade point averages, don't really predict how well Google employees perform at the job. So it's just not really particularly helpful when Google looks at all the, let's say, 1,000 people they hire every year. the grade point average of these people from their college degree does not really help explain who performs well at Google. And then one could think, well, should a typical Danish firm then also just ignore grade point averages? Well, Google only hires employees with very, very high grade point averages. Basically, if you are from a Danish institution, you more or less need an average of almost 12 in order to get a good chance of getting a job at Google. So there isn't really any variation in grade point average to take departure in. So, of course, if there's no variation in the variable that we're interested in, this variable is not going to help you explain how well people perform. Similarly, if we look at the height of NBA basketball players in the United States, they don't really predict scoring very well. This does not mean that height doesn't matter. Of course height matters. It just means that almost everyone that gets into the NBA are already very tall, which means that this factor is not going to play a big role. So typical Danish firms should probably not hire like Google, because the variation in the kind of people that you get in and the grade point averages, it's much, much bigger. So one should not necessarily look at Google and Amazon and Apple, etc., to see how they hire people and just copy their hiring approaches, because they might not really translate very well to other kind of settings where you get other kinds of applicants. This is also related to this issue of selecting on a dependent variable that I already mentioned once. So let's say we're interested in how successful entrepreneurs, they do well, and we end up only studying successful entrepreneurs. Well, we might not really find out that unsuccessful entrepreneurs might do the exact same thing. Maybe they try to engage in most of the same practices, but just fail for various reasons, whether it's luck or a factor that we have omitted. So if we want to explain how a certain group does well, entrepreneurs or basketball players or CEOs or businesses or whatever we're thinking of, we should not only look at those that actually do well, because we risk missing some really key information. For instance, that those that don't do well just end up doing the same thing. In principle, there could be industries where it's pure luck that decides whether you succeed or not. And you'll only find out about that if you look at both those that do well and those that don't do well. So always pay attention to, in a study, if they say you should do this or you should do that, well, who have they looked at in order to reach that particular conclusion? You can also imagine a study that says, look at all these companies that successfully managed the COVID-19 crisis. This is how they survived. Well, again, look at those that might have tried the same thing and failed. So don't just select on the dependent variable. Don't just select on the outcome that you're actually interested in, but make sure that you have variation in that outcome. Then the article also talks about the construct creation, or what's the sort of the relation between the data you collected and the actual theory. So, and again, maybe insightful to refer to the face mask example that I've given before. If you claim to have measured the effectiveness of face mask, well, it might not be ideal. It's not really ideal only to actually get data on whether people received face mask in the mail and an encouragement to use them. That's not directly measuring the effectiveness of face mask. That's measuring the effectiveness of encouraging people to use face mask. So the theory should not be on the effectiveness of face masks. The theory should be on the effectiveness of encouraging people to use face mask. And the same thing with all the range of other elements that I'm mentioning here. Always pay attention to, if you claim to have measured employee performance, well, what is actually being measured here? Is it the manager's subjective assessment of it? Is it some more objective criteria that is being followed? The same with firm performance, and can often be measured in many different ways. So one wants to pay really attention to that the concepts you use in your theory and the words that you use in your theoretical framework also match the actual data that you collected. And then there is one mention that is probably a little bit more complicated to get your head around. Something called common method variance or common method bias. It has both of these names. And the point is that you should be careful, for instance, in a survey setup, if your independent and dependent variables stem from the same source. Let's provide an example. Let's say you want to investigate what employee characteristics leads to high job performance. We could have a setup where we send a survey to managers that are to rate both the characteristics of the employees and the performance of the employees. But this then could create this common method bias, because it could be that the manager's particular thoughts on useful characteristics, maybe a manager in particular likes a certain gender or a certain education or a certain attitude. And this then also leads this same manager to assess the performance of these employees in a particular way. So it's actually just the manager's liking of a certain kind of quality that also leads them to rate the performance higher, even though the performance in actuality is not necessarily higher. So we have the risk of a common method bias, because the data that we're getting on both the independent and the dependent variable is from the same source. We risk that it's systematically skewed by the same source assessment of both of these elements. So if the source is biased, the biases influences both the independent and the dependent variable in the same systematic way. So you might end up with something that is very significant and looks very substantial, but it's just an artifact of the way the data is collected. So just then briefly put, it's much better to have an independent source on each of these. So ideally you would have one, for instance, one manager or some range of people assessing the characteristics of individuals, and then another range of people or other managers assessing the performance of these employees, because then you don't have this systematic overlap in where your information is coming from. So ideally you have multiple sources to get your data from. It just leads to a stronger stronger data set, a stronger design, and a stronger ability to get to the conclusion that you actually want to get to. So these two videos have tried to give an overview of overall research designs, strengths and weaknesses of them, and also some more particular and sophisticated elements that the AMJ article goes into. This AMJ article also goes into topics that you will be required to get have an understanding of, to already have an understanding of when you're at the master's level. So that's why I'm also already pointing to them here. And here, the last slide, I've just given some very general and some very rough rules of thumbs of advantages and disadvantages of the various kinds of research designs. These are really just very rough. It's not always the case that a cross-sectional design will have a strong external validity, and et cetera, et cetera. It's not always the case an experiment will have a weak external validity, but these are some general rough characteristics that can help one make sense of different research designs. In the next session and in the live session, there will then be focused on quite a few different examples of different research designs and how they can complement each other in order to get a sense of what do they do, what are they, and how can we assess the quality of these. So that will be the focus in the next session.